Hello everybody, today we're going to be working on graphing the sine curve. So the sine and cosine graphs are periodic or cyclic, meaning that the dependent variable takes on the same value over and over again as the independent variable increases. So what it just means is that the y values are going to repeat as we continue moving forward with the x values. So the first definition we need to know is the cycle of a periodic function. That is a portion of the graph from one point to the point where it repeats itself. And we also have the period. That is the change in x corresponding to one cycle. So if we take an x value and add the period to it, it's the same as if we just found f of x. And that's for all real values of x. The next definition we have is amplitude. That is the distance So next we have amplitude. That is the distance from the node line to the high or low point. The next we have is phase shift. That is a horizontal shift. And it can be left or right. And I know that this is a lot of definitions and they might seem overwhelming or confusing, but we're going to use these in context a lot. So as we use them, they're going to get very easy to understand. Then frequency is the number of complete cycles in 2 pi or 360 degrees. So remember on the unit circle, at 0 degrees or 0 radians, this ordered pair is 1, 0, and the ordered pair is cosine and then sine. So if we look at the normal sine curve, the first point for 0 radians is going to be that the sine of 0 radians is 0. The next main point we're going to look at is up here, which is pi over 2. So I'm going to put that as the next marker on my graph. For the ordered pair here, we know that that one is 0, 1, and that's cosine and sine. So the sine of pi over 2 is 1. The next point we're going to look at is pi. And we know that the ordered pair is -1, 0. And our ordered pair is cosine, sine. So the sine of pi is 0. And we're going to look at 3 pi over 2. We know that ordered pair is 0, -1 with cosine and sine. So the sine of 3 pi over 2 is -1. And then we get back all the way around the circle to 2 pi, we know that the sine is 0. I'm just extending my line since I didn't space it that well. And so my curve looks like this. And this is why it is a periodic function, because it just really keeps going around and around the unit circle, so it's going to keep hitting those same values. Now, some important things to know. We call this line that's in the middle, this is called the node line. Then the highest value we call the crest, and the lowest value is called the trough. The period of the normal sine curve is 2 pi because it took 2 pi to repeat the original point. The amplitude is 1 because the distance from the node line to the crest or to the trough, that distance is 1. An important thing to know is the amplitude is always positive. So the parent function for the sine curve is y equals a sine b times x minus c plus d. A is always going to be the amplitude, so how far from the node to the crest and the trough. B is the frequency, that's how many times the graph repeats in 2 pi or 360. C is the phase shift. Oops, that should be an F, a P there. And remember, it can go left or right. If it's a minus in there, it goes to the right. If it's a plus, it goes to the left. And that's because the parent function has minus, so it always switches the sign there. And then D is where the node line is, or the center. And the node line is always the equation y equals d. We can also think of this as the vertical shift. And then an important thing to know is to find the period. You take 2 pi and divide it by b, because it's just 2 pi divided by how many times it repeats in 2 pi. So if we move on to the next page, we're going to practice sketching one cycle of each graph. So if we look here, we know that there's a lot of information to unpack. Now, in order to find where one cycle lives, we know that in the parent function, one cycle lives between 0 and 2 pi. And I know we're in radians because of this pi over 2. Now, in the parent function, or in the normal function, there would just be x in here. There would be nothing else. But all of those things inside of the function are impacting where one function lives. So to find where one cycle lives, to find one cycle in this transformed function, we're going to take what's inside the function and then solve for x. So first thing we do is divide by 4. So we have 0 is less than or equal to x minus pi over 2, which is less than or equal to pi over 2. Once we get rid of a number in front of the parentheses, that always gives us our period. You can always find that later too by doing 2 pi over b. All right, then we can add pi over 2. So we get pi over 2 is less than or equal to x is less than or equal to pi. So this is going to be where one cycle starts and ends. So if I start sketching my graph over here, so I'm going to draw a break in the x-axis because we're not going to stretch this out evenly across the x-axis. We're only going to show the part where one cycle lives. So I draw a break because my jumps on the tick marks I make are not necessarily going to be even from 0. So I'm starting at pi over 2, and I know that I end at pi. Now, if we look back here, from where we started to where we ended, there were 3 points in the middle that divide it into 4 equal parts. So the way that I like to find these other values is I divide this by 2. So between pi over 2 and pi, the middle of that is going to be 3 pi over 4. And you could always find that by averaging them, so adding them together and dividing by 2. And then again, I can find the middle here, so you could add them together and divide by 2 if doing it in your head is not something you're so good at. It's going to be 5 pi over 8. Sorry, my pen is really being uncooperative today. And then this point over here, again, I could average them. It's going to be 7 pi over 8. Now, to find the node, crest, and trough, what we want to do is first look at the vertical shift at the end. So there's that +1 there. So that means our node line is at y equals 1. So this is going to be the middle. Then I know that the amplitude is 3 because it's the number in front. So then to find my crest and trough, I have to add and subtract 3 from the node line. So the crest is going to be at 4, and the trough is going to -2. All right, and so then we can start creating our graph. Now, we know that in the sine function, if we think about the parent function just right on the unit circle, that first point is 1, 0. So what that tells us is that the sine curve starts at the node line. So that means my first point is going to be at pi over 2, 1. Then the second point on the sine curve we know is at 0, 1. So normally it goes from 0 to 1, which means it goes from the node to the crest. We're going to go to the crest here, then back to the node, down to the trough, back to the node. We're always going to follow that pattern. And that's our graph. So let's look at another one. Let's look at number 2. So we're always going to start by finding where the one cycle lives. So we're going to use that inequality. Now in this problem, we've got 2 pi again. So first thing I need to do is multiply by 5 over pi. And this is our period because there's nothing in front of the parentheses anymore. Then I add 3, so I get 3 less than or equal to theta less than or equal to 13. So I'm going to start my sketch. And again, I'm going to draw a break in the graph since I'm not starting at 0. I know I'm going from 3 to 13. Halfway between 3 and 13 is 8. Halfway between 3 and 8 is 5.5. Halfway between 8 and 13 is 10.5. So then we want to start looking at the vertical movement. So we know that the node line is going to be y equals -2. And then to get our crest, I'm going to write the amplitude down first. The amplitude is 4 because it's always positive. So to get my crest and trough, I add and subtract 4, so that's going to be positive 2 and negative 6. Now, an important thing to notice here is we have a negative 4 in front of the parentheses, so that means we're going to start at the node, but then go down. Because we always start at the node for a sine curve, but if it's negative, it has a vertical reflection, so we go down. So we're going to start at the node, so 3, negative 2, then we're going to go down, then back to the node, then to the crest, then back to the node. There we go. So let's just go ahead and look at this next one. This one is in degrees, so we're not going to practice actually graphing it. We're just going to look at finding our information that we need. So the amplitude is always the number in front, and it's always positive. So in this case, it's 2. The frequency is the number in front of the parentheses, so that's 3. To find the phase shift, that is based on the number inside of the parentheses. So we have the plus 30. So that means that we have to go to the left by 30 degrees. The vertical displacement is the D, or the last number at the end there. So we are going to be going 7 up. Then the period of one cycle, remember to find the period, we do 2 pi over b. So in this case, it would be, this one is 30 degrees here. So that means that this is going to be in degrees. So we're going to do 360 over b, which in this problem, that's going to be 360 over 3, which is 120. The equation of the node line is based on the vertical displacement. So that's going to be y equals 7. And then the maximum y value, we take the node line and add the amplitude. And the minimum y value, we take the node line and subtract the amplitude. And that's it. So that's all I've got for you for this video. If you have some questions, make sure you try rewatching the video and then reach out to me so we can get those taken care of. Good luck.